Hello to all fans of physics, astronomy, mathematics, and the exact sciences. I'm Andrei Shketnikov, and today we're going to talk about an astronomical measure, the brightness of stars in the sky and other objects, such as stellar magnitude. Well, in general, all stars by magnitude suggested. In the 2nd century BC, the famous ancient astronomer Hipparchus classified them. He proposed that the brightest stars be considered first magnitude stars, while the faintest ones that are still visible to the naked eye be classified as 6th magnitude. He evenly distributed the others among these categories, and he suggested that the brightest stars be considered first magnitude stars, while the faintest ones that are still visible to the naked eye were classified as 6th magnitude. Well, the others were evenly distributed among these categories. Of course, all of this was done by eye, and it required he classified the faintest ones as 6th magnitude, while the others were evenly distributed among them. Well, obviously all of this was done by eye and required. Modern astronomers now have a more precise measure, and in 1856, the English astronomer Norman Pogson proposed a mathematical representation of stellar magnitudes, and we consider that a 0 magnitude star and a 5th magnitude star differ in brightness by exactly 100 times. And now let's see what such a definition leads to. And we need to ask ourselves, if a 0 magnitude star is 100 times brighter than a 5th magnitude star, then how many times a 0 magnitude star is brighter than a 1st magnitude star? A 1st magnitude star is brighter than a 2nd magnitude star, and so on. And this is it. We'll denote the brightness ratio of 2 adjacent magnitudes on the scale as x. Brightness factor x per step. X over 5th root of 100. 2, 51. At each step, the brightness decreases by a factor of x, and over 5 steps, it decreases by x to the 5th power, which equals 100. So we have a simple equation where x is the 5th root of 100, which is approximately 2.51. So we have this scale, and here we can delve deeper into the math. This scale is logarithmic. I think it's enough for each of you to ask yourselves how many times a 0 magnitude star brighter than a half magnitude star. 0.5. You can even pause this video and write down your answer and continue watching my reasoning. And so far we have introduced the scale of ratios, and now we need to tie it to something so that we have a reference point, and for this reference point astronomers agree to choose Vega, Alpha Lyrae, and consider that it's the visible stellar magnitude is equal to more 0. They write it as 0m, like this. Well, then, the brightest stars in the sky. The brightest star is Sirius. And since it is brighter than Vega, its stellar magnitude will be negative, approximately around the value of 1.46. Well, among the brighter objects, we also have Venus in the mornings and evenings at its maximum brightness. Its brightness reaches minus 4.6 in stellar magnitude, which means that if it were minus 5, it would be 100 times brighter than Vega. Well, actually, the brightest star in our sky is the sun, and the sun, its brightness is minus 26.7 in stellar magnitude. Well, scale is logarithmic, and that's why this is 26. We remember that each 5 represents 100 times. 25 is 5 times 5. And if it were minus 25, that would be 100 to the power of 5, which is 1 followed by 10 zeros, 10, a billion times. If it were minus 25, that would be 100 to the power of 5, which is 1 followed by 10 zeros, 10, a billion times. And so far we've been comparing stars based on their apparent brightness in our sky. This is called apparent stellar magnitude. But, of course, we can also compare stars by their absolute brightness to see which one is brighter and which one is dimmer. And astronomers came up with the idea of keeping the same scale to imaginatively place each star at a distance of 10 parsecs. By the way, about what a parsec is, which is equal to 3.26 light years, I recently made a video on that. You can check it out. The link is below. Placing stars at a distance of 10 parsecs, and A star would look at this distance, and this is called absolute stellar magnitude. Well, if our little sun were at that distance from us, then stellar magnitude would be plus 4.8, so it's at the limit of visibility. But it's still visible, a very faint little star, Sirius, which is the brightest in our sky. If you move it to a distance of 10 parsecs, it won't be as bright. Its brightness will be plus 1 quart. Stellar magnitude, because it is relatively close to us, 8.5. Light years is 2.6 parsecs. And a star like Betelgeuse, Alpha Orionis, is actually quite visible in the sky right now during winter. It's all very far from us. 548 light years, 168 parsecs. And if you bring it closer to a distance of 10 parsecs, it will shine with a brightness of minus 5.8, an absolute stellar magnitude. But it's the brightness that Venus has when it shines the brightest in the evening or in the morning in the sky. So what do the little stars look like in the sky, and how bright are they? In fact, so to speak, in absolute terms, it can vary greatly, because the distance to stars and their brightness, they are all very different. Well, I think we can wrap up this video. Write your questions, comments, and thank you all very much for your attention.